Good evening. My name is Vinosha daughter of Raman. Today we're going to present about our assignment 1 that's about current transformer failure. Okay, first the incident happened on Friday 13 August 2004. Uh, the time that happens is 9:41 p.m. Next. At 9:41 p.m. on Friday, August 13, 2004, a current transformer at the Bay Water Power Plant in New South Wales suffered an internal fault, leading it to explode. This collapse prompted a surge power system even in New South Wales, resulting in the loss of 5 big producing units and 1 medium capacity generating unit. Because of the rapid loss of generation, the power system frequency fell to 48.9 Hz, resulting in about 1500 megawatt of under frequency load shedding. Queensland, New South Wales, Victoria, and South Australia experienced load shedding. This automated load disconnected together with the combined reaction of the remaining producing unit effectively managed the power system frequency and avoided a significant power system collapse. Okay, next. Okay, next slide present by Aisha.
This is the protection system in this incident and how it's operates. The base water unit 1, 2, and 3 were tripped by the operation of the generating unit differential protection relays. The fault on the current transformer was detected by the protection system on the 3-4 line, which act automatically to open the 34 line circuit breaker. The current transformer fault was then isolated from the power system by the open circuit breaker. The auto reclose is operated to ensure that the transmission network is restored to the full capacity as soon as possible. But the fault on the current transformer was still present, and the auto reclose of the main bus circuit breaker result in the fault being reapplied to the power system for a second time and third time. Next. Okay, this figure show how the protection system happen. They open the circuit breaker and close it, and then for the third picture, the circuit breaker reclosed and the fault being reapplied to the system. Okay, next. Okay, the source of the incident. The main cause the incident happened is due to the earthing lead from the condenser bushing fault test terminal caused the current transformer to fail explosively. Okay, next.
My name is Jason. Analiki Kulasigaran. My metric number is P08191618. This is a current transformer. This is a high voltage terminal voltage. High terminal voltage. The down is secondary terminal box. The side is gas cushion. Next slide. Explain the impact and the consequence of the incident. Safety. Current transformer should not be disconnected from this button while the current is in the primary, as the secondary will be attempt to the continue driving current. Next is health. Wear a personal protective equipment so that it can be prevent from damaging our health when working in hazard environment. Third is cost. Based on the incident that happened, the cost will be for the repair and the maintenance, as the transformer has totally went down due to the incident. It will be one of the biggest consequences in case of the event like happen elsewhere. Last is transformer is damaged. Transformer number 6 has been damaged due to this incident that happened in base water, while the other equipment in the still intact and ready to use. Next slide, Ikram will present it.
Okay, so based on the technical report, what I have understand is that most of the evidence suggests failure in the earthing leg from the condenser bushing foil test terminal caused the current transformer to fail explosively. Okay, they were not aware of any specific operating conditions, either system or environmental, that are of such a severe nature at this site that they are likely not to have contributed to the failure. Number three is there were previous incident at Bayswater in 1995 and 1998 involving the failure of 330 kV current transformers. Following those events, in the mid to late 90s, Transgrid installed monitoring facilities onto the current transformers, including the one that failed on 13 August 2004. It is understood that these monitoring facilities are to provide early warning of potential failure of the current transformers. However, the failure that occurred in 13 August 2004 was a different failure mode to those that occurred in the 90s, and for this reason, the monitoring facilities that were installed did not provide early warning of the fault. So based on the technical report, this is what I have understand. Okay, next slide. Okay, so the issues regarding health, safety, and legal, and also cultural. Okay, so after reading the report and finding for the issues, there were no issues regarding the health, safety, legal, and cultural issues based on what I've read. However, in my judgment, if there is no issues during the incident, it will be an issue if the incident repeatedly happens without any solution. The report also states that the incident were taken care of in less than a minute to continue the operation. If these issues still happen, it will cause the safety and health of the person that is working on site. So there were no human contact when the incident happened, so there were no safety issues or health issues because they were monitoring the system and they opened and closed the relays, which means the transformer that exploded, the relay was open, and the backup transformer, the relay was closed. So the backup transformer was generating current supply. So there were no one handling the situation on site. So there was no issues. Okay, next slide. Okay, this is examples of issues that may happen if there were any person in the site working and suddenly the incident happened. So for safety and health issues, it may cause death, it may cause of having certain occupational disease, and it also may cause to certain chronic disease. For legal issues, company may be shut down or operation is terminated. It may cause money losses to the company, and the company will also be not trustworthy because incidents like this, if it happens repeatedly, then the company should not be trusted to supply a big amount of current to the place. Okay, next.
Slide about how to prevent this event in future. First, system safety, stability, and efficiency of power supply system must be improved. Second, make consequence of high insulation power factor values because other major reason for the continuous online condition monitoring approaches that provide that data trending and early warning of an impending current transformer failure. Okay, that's all from us. Thank you.